All right, today we've got a real geological detective story for you. We're going to be investigating a single piece of granite that, get this, has two different birthdays, and they're millions of years apart. It's this incredible rock that tells a tale of a crystal heist, and even helps us piece together a lost connection between continents. It's a fun one.
So our story starts right here on the absolutely beautiful Palm Beach in South Africa. We're looking at this outcrop of rock called the Portobello Granite. And, at first glance, it just looks like any other rock you'd see on the coast. But, as geologists would soon find out, it's holding a secret that's over 1 billion years old. And this is the central puzzle. This is where things get really weird. When scientists dated the main body of this granite, they got an age of, about 1,057 million years. But then, when they tested the rock right at its edge, its margin, they got a totally different age, 1,093 million years old. That's a 36 million year difference in the same piece of rock. How on earth is that even possible?
All right, so to solve this mystery, we've got to zoom out a bit. We need to examine the bigger picture, the geological crime scene where our mystery rock is located.
This whole area is known as the Natal Metamorphic Belt, and geologically speaking, this place is, well, it's not exactly a quiet neighborhood. 1 billion years ago, this was a massive collision zone. You had these ancient chains of volcanic islands, which we call terranes, that just smashed right into the ancient core of the African continent. Yeah, think of it like a 1 billion-year-old traffic pileup, but on a continental scale.
So you had 3 main terranes, the Tugela, the Mazumbe, and the one we're really interested in, the Margate, and they all crashed together right here. This whole history of intense collisions, melting, and mountain building created this incredibly complex geological landscape. And our mystery rock? It's just one tiny piece of this much, much bigger puzzle.
So, you might be wondering, how do you even date a 1 billion-year-old rock in the first place? Well, the answer lies in some of the tiniest and toughest little clues on the entire planet.
Okay, let me introduce you to the hero of our story, the mineral zircon. See, when magma cools, these tiny little crystals form, and what makes them so special, so perfect for our detective work, is that they lock a little bit of uranium into their crystal structure. Now that uranium decays into lead at a perfectly steady, completely known rate. So all scientists have to do is measure the ratio of uranium to lead, and bam! They can calculate the zircon's age with incredible precision. They're basically nature's most reliable little timekeepers.
Okay, now this is our first major clue. Take a look. On the left, you've got the zircon crystals from the older margin of the rock. See how they're clear, pristine, beautifully formed? But then look at the ones on the right. Those are from the younger main body of the granite. They look all milky, kind of diffuse, and, well, altered. This visual difference is a huge piece of the puzzle.
And it's not just us noticing this. The original scientific paper points this out directly, talking about that stark contrast between the milky zircons and the transparent ones. So the clocks themselves actually look different. This is a crucial point. We're not just looking at 2 different ages, we're looking at 2 totally different types of zircon crystal.
Okay, let's recap our case file here. We've got our motive, a rock with 2 ages. We have our crime scene, this super complex collision zone. And we have our forensic evidence, 2 totally distinct populations of zircon crystals. It's time to put the pieces together and solve this thing.
So, this is the million-dollar question, right? If the main granite magma formed 157 million years ago, where in the world did it get a whole batch of pristine 193 million-year-old zircons? And why did they only end up right along its edge? It just doesn't add up.
And here it is. This is the smoking gun. The geologists went and dated the rock right next to the Portobello Granite. This is the older country rock that was already there before our magma showed up. And what age did they get? 1091 million years. Just look at those numbers. The age of the granite's margin, 1093, is, within the margin of error, a perfect match for the rock right next door.
Come on, that is not a coincidence. What this means is that the older age we found in the granite's edge, it isn't the granite's age at all. It's the age of its neighbor. So the question now becomes, how did the neighbor's age get inside our granite?
Well, this brings us to a really cool geological concept called xenocrysts. The name literally means foreign crystals, and that's exactly what they are. You can think of them as geological stowaways. They're these tough little crystals that get picked up from an older rock and mixed into a younger magma. But they're so tough they don't melt.
They literally just come along for the ride.
And this is exactly what happened here. It was a great crystal heist. So, picture this. About 1057 million years ago, this big body of hot magma starts pushing its way up into the crust. As it moves, its intense heat melts and, well, assimilates the edges of the older rock it's pushing into. And in that process, it basically steals the tough little zircon crystals from that older rock. So when the magma finally cooled down, these stolen zircons, our xenocrysts, were frozen right into the margin of the new granite, perfectly preserving their original older age. The perfect crime.
So, case closed, right? Well, not quite. See, solving this puzzle actually opens the door to an even more interesting story about a very special type of rock that was created during this whole heist.
Remember that distinct, darker-looking edge of the Portobello granite? Well, that's actually a special kind of rock called a charnockite. Now, your normal, everyday granite has minerals in it that contain water. But to make a charnockite, you need two things: extremely high temperatures and very, very dry conditions, with almost no water around. That allows a totally different mineral, orthopyroxene, to form instead.
Now, as it turns out, geologists know of 4 main ways to create the super hot, super dry conditions you need to make a charnockite. And what's so cool about this is that our Portobello granite is a perfect, real-world textbook example of number 2 on this list. You have a relatively wet granite magma that becomes locally dry simply by melting and mixing with the dry country rock that it invaded. So think about that. The exact same process that stole the zircon crystals, that assimilation process, also changed the chemistry of the magma right at its edge, just enough to create this rare and unusual rock type. Our little geological mystery here turned out to be a perfect natural laboratory for understanding a major geological process. How cool is that?
But believe it or not, the story still doesn't end there. Those tiny little zircon crystals, they have one more, even bigger secret to tell. And this one connects this single beach in South Africa to an entirely different continent.
Get ready for this. While they were sifting through all those stolen zircons, the scientists found one tiny zircon core that clocked in at 1.8 billion years old. That's nearly 700 million years older than any other rock found anywhere in the entire region. It was like a xenocryst inside a xenocryst, a true ghost from a much, much more ancient past. And here is the final amazing twist. When geologists compared the specific sequence of rock ages they found in the Natal Belt, you know, the 1090 million-year-old event, the 1060 million-year-old event, they found it was a near-perfect geological fingerprint for another place on Earth, specifically the Vardekeltane terrain in Dronning Land in Antarctica. Yeah. The scientists themselves concluded that these dates directly confirm the link between this piece of South Africa and that specific piece of Antarctica. They were once one and the same piece of land, joined together in the ancient supercontinent of Gondwana before they were ripped apart. The clues in this one single rock formation are helping us physically stitch the continents back together. It's just mind-blowing. So, from what started as a simple puzzle about one rock with 2 ages, we've uncovered this incredible story of a crystal heist, the formation of a super rare rock, and even the ghost of a lost supercontinent. It really just makes you wonder, doesn't it? What other ancient, incredible stories are just waiting to be read, locked away in the rocks right beneath our feet?